Good. Okay, today's presentation is about Kubernetes, and it's about things that you can do in Kubernetes that are going to be important coming up in this year. There's things that you can do now. It's a very fast-moving platform, a lot of things changing. So this is kind of a point in time showing some things that if you've been working with it, you might not be familiar with, or you might have heard about, but you didn't have much information about. So we're going to jump right in. These are the topics we'll be covering. Kubernetes first, or Kubernetes native applications, Kubernetes and the hybrid cloud, containers and Crypto, which we'll explain when we get there, using Kind to try out multi-node clusters, and Kubernetes skill sets and training. So we'll start off with is Kubernetes first applications. So they're also called Kubernetes native applications. Okay. The idea here is that before now, chances are that you were trying to take an application that had been written on its own and then adapt it to work in Kubernetes. Kubernetes, for those of you who are haven't spent a lot of time with it, Kubernetes is a framework for creating clusters. So you can have multiple machines running a single application. And you can have multiple applications running within the cluster. You can have multiple clusters. And the benefit you get from Kubernetes is high availability, high throughput for your application, things like that. Okay, so starting not too long ago, this concept of creating an application and from the very start designing it to run on Kubernetes, this has become something that's quite important. If you know the application is going to need to scale, so you're going to have to run multiple instances of it, and it's going to have to run in a clustered environment, then it's good to develop it from the start to work with Kubernetes. Okay. Some of the things that you normally do in running those or creating those types of applications is to follow the 12-factor development principles. We won't go over that here today, but they're generally principles that if you follow them will make your applications fit into this type of clustered framework for running and work very well in that environment. And Kubernetes also relies on containerization. So that's the idea that you would be running applications inside of a container, inside of then an operating system or virtual machine, right? So containerization means that whenever you run the container, everything that's needed for the application is already built into that, okay? And when we're talking about containerization, the word that comes up is usually Docker. Docker is one of the biggest container management applications that you can work with, and Kubernetes works with that. So the idea of using Kubernetes to fill in some of the features of your application that you would normally have to write on your own is what this Kubernetes first or Kubernetes native applications is about. Okay, so if you know you're going to be running in your application in a cluster, then you can take advantage of some of the features that Kubernetes has to handle things like logging and security and things like that. So the integration that you're going to do when you are creating a Kubernetes native application will apply to all the different stages of application life cycle. So there's going to be things that happen during the build, the deploy, the run, and the manage stages. And that's what we'll take a look at first. So in the build stage, one of the things that'll be different is that you are going to be starting by creating your cluster. And to create your cluster, you're going to need to generate some things like containers, Docker containers, or images that can be used to create Docker containers. Those things are built at this point during the build stage. In fact, you could do it in your pipeline with your build management tool. Okay, and then pod configurations. Pods are where your applications are going to run. It's a virtual environment that includes virtual machines or nodes on which your applications run. So the configurations for those things, you're going to be already thinking about that in the build stage of your application. The deploy stage, you're going to actually deploy the application even during development into this cluster that you've designed during the build stage. And you're going to start doing your application debugging and testing using various Kubernetes mechanisms. Okay, you'll need to set up things like routing and networks within Kubernetes in order to access your application in the cluster. You'll set up security so that it's not apart from the type of security that is handled by Kubernetes. And then you'll take advantage of Kubernetes mechanisms for logging and for error handling, things like that. Okay, so you're building your application knowing that these capabilities are going to be available. When you get to the run stage, and this could be the run stage during development or the run stage when you go into testing or deployment, you're going to use things that are part of Kubernetes like health probes. You'll use replica sets in order to replicate your application. So you won't have to build your own way of spawning multiple processes of your application. You're actually just going to be using the replica sets that are part of Kubernetes to do that. And then in order to make sure that your applications are placed in nodes, which are machines or virtual machines that can handle the workload, you're going to take advantage of Kubernetes pod scheduling. Scheduling here is an odd term that they use. It applies to looking at what an application needs and making sure that gets loaded on the hardware that's available that can handle it. So if you have an application that says that it needs a certain amount of gigabytes of storage space, then Kubernetes will look through all of the nodes that are available and find the one that has the storage space that's available that you need, and it'll place your application there. So it'll intelligently figure out where your application should go, and that has to do with it'll select based on any resource, so not just storage, but memory. If you need a certain amount of memory, it'll look for a machine that has that memory. If you need so many CPU cores to run, then it'll look for a machine that has that. So you'll be keeping that in mind, as opposed to just doing your testing or your development on a single instance of your application and then worrying about deployment later. You'll be thinking about these things at that point. And then the management stage, there are things you do to manage an application, okay, that can be done through Kubernetes. Okay. The first thing is just monitoring the cluster itself, which is the infrastructure that's being used to load and run the applications. Okay. And then you can keep track of things like networking, and you can put in monitoring. There are tools that you can hook into Kubernetes that will do very detailed monitoring of the type of network requests that you get into your application and keep track of that kind of stuff. And you'll monitor that to monitor the health of your application. Okay, so we mentioned that you'll be using these features of Kubernetes, but the question is how do you do that? And there's a couple of ways that you can do that. One is using Kubernetes operators. Operators are ways to enhance Kubernetes for specific applications. It's kind of like creating an add-on, okay, that runs in the main section of the Kubernetes cluster, the control plane. And that add-on can be used to do all kinds of things, like to help during installation, to help during upgrade, and to help run backups and do things like that. So it's active code that you can write, and you can place it inside of Kubernetes. Another way of implementing some of the features, for example, logging features, is to use something called sidecar pods. Okay. Generally, when you create a pod is a virtual environment that usually includes a single container. That container being a place where applications can run. So you'll have one application in one container in one pod. That's kind of a basic setup. But when you're doing these Kubernetes first applications, a lot of times you want to create separate applications that are just used to help monitor or work with along with your application, and they can then sit in a separate pod or a separate container in the same pod, and then do some work on behalf of your application. And the reason why they can do this is because when you're inside of this virtual pod environment, each of the containers can share the resources that are being used by the others. So your main application uses some resources, maybe it uses some disk space, some storage, and your sidecar pod, which is your second pod, allows you to run an application that just works with that storage. The classic example of that is a log handler. So a log handler whose only job is to sit there and wait for the logs to be filled up to a certain level, and then it ships them off to another log server or something like that. So instead of having your application do that, you have it done inside of a separate application in this sidecar pod. Okay. So to go back to operators, operators are these extensions. They're used to manage applications. So you would write an operator in order to manage things about your application, and they can do things like this. They can automate deployment and configuration, automate the scaling of your application if there's some special way that you need to detect when your application needs to scale. That can be built in and automated. Monitoring of your application and sending out alerts can be done through an operator. You can have an upgrade procedure, so instead of building that into your application, it can be built into an operator. And then reacting to any issues, that kind of goes hand in hand with monitoring, right? So you monitor, and then you call whatever you need. If you need to send an email to an administrator if there's a problem, or if you need to run some process to free up space, those kinds of things. The reacting to those issues can be done inside of an operator. So the thing about operators is that they are extensions. So they extend Kubernetes without actually having to modify the code of Kubernetes, right? So that's really helpful. You don't have to wait for somebody else to build an operator that does what you want. You can actually just go in and build one and deploy it inside of your cluster. Okay. So some of the things that these are used for: a deployment of applications. And you can deploy applications based on trigger conditions. There may be applications that you run that aren't used constantly. You don't run them and then they leave them running all the time. So there are some applications that just wake up at a certain time of the evening, send out emails or do some kind of work, and then they go away. You can have an operator manage the deployment of those applications based on trigger conditions. Okay. You can back up application state. So this kind of maintenance operation that you would maybe normally have to do manually, you can build into an operator. so it can be automated. Okay. Anything having to do with installations or upgrades can be built into the operator, so it can be done reliably and predictably. Okay. Now, there are some operators that are available that are already built, ready-made operators, and generally those operators go along with certain applications that you might already be working with. Okay. There's a couple of examples are listed here, and you see for MongoDB, there's an operator for that. Okay, that will help you do the kinds of operations I just mentioned, installation, upgrades, and things like that. Okay, the other examples here for the role-based access control, there's a manager operator that makes that a little bit easier to configure, even though that's a feature. RBAC is a feature of Kubernetes. It's one of the ways that you can manage security. Okay, to make it easier, there's an operator that you can use. Same thing for the etcd key value storage, which is part of Kubernetes. It's used to keep Kubernetes configuration information to help manage that, manage backups and things like that. You can use the etcd operator. Okay, and if you go up on this site, you'll be able to see this whole bunch that you could possibly use. These are ones that were already built that work with applications that you might already be using. Okay, but you can also create custom operators to work with your application. So something that just does those operations, those maintenance and automation operations for the application that you've developed. Okay. So we had talked about pods and having a multi-container pods. Okay, so we'll talk about that just a little bit more here. The sidecar is this pattern where you're running a utility or some other application alongside the application that's your main application. So if you have a web server, you might have an application that handles its log files, okay, that ships those log files or checks them or does something like that. And you have that within the same pod in a separate container. Okay, so you can do things like application monitoring with a sidecar application. You can do log management. Okay, and the reason why you're placing it in the same pod is so it can share the resources of the main application. So when the main application saves its logs to some storage, the sidecar pod has availability to that to work with what's on that storage, so it can pick up those files and do something with them. Okay, so here's a summary of what we're talking about with Kubernetes Native. It's building your applications from scratch to take advantage of all the different features, or even just some of the features of Kubernetes clustering. That's to say, in addition to the clustering part, right? That's the main feature that you're taking advantage of. But there's other features like log handling and monitoring and metrics gathering and things like that that can all be used by your application, so you don't have to write those parts of your application from scratch. You can use what's part of the infrastructure. Okay. So these applications, supposedly, when you create them in this way, you can make them easier to deploy because they're more aware of Kubernetes itself. You can have them handle failures and restarts better. So, for example, if your application crashes, it should be able to come back up in a seamless fashion. And that's a partnership between Kubernetes and your application to restart an application. Okay. And you want your application to be able to handle changes in the back-end availability. So if your application uses a back-end data server or a network server of some type and that goes down, okay, you want your application to be able to detect that back-end system is down, and then to maybe fail over to another system if possible. Okay? And you can do that by detecting that failure through some Kubernetes mechanisms. Okay? And the other thing is to handle loads, high loads. You want your application to handle the traffic that's coming into it predictably and reliably, right? So it should always do the same thing no matter what the load is. Each request that comes in should be handled in a consistent way. Okay, and you can use some of the features of Kubernetes to make sure that happens. Okay. So that's, there's a question of whether you want to think about that for your next application, or maybe you're already working with development of an application where you want to try to stitch in some of these features of Kubernetes into the application so that it can benefit from them. Okay. We'll go right on now to the next topic. The next topic is Kubernetes and the hybrid cloud. Okay, so we'll start off by just talking about the hybrid cloud, right? So you have these cloud providers like AWS and Google, Google's App Engine and things like that, with a lot of capabilities where you can run your applications in the cloud. You also have a need in many cases to run your applications on premises. Okay, so hybrid cloud is mixing those two, mixing the computing, storage, and services, so that some of your applications run on premises, some of them run in the private cloud, and you can mix and match and take advantage of the benefits or advantages of the one method of running that works for a specific application. As far as Kubernetes in the hybrid cloud, it's getting easier and easier to run Kubernetes clusters in cloud environments, because all of the different public cloud services have put up Kubernetes services to make it easier for you to start up a Kubernetes cluster. So whereas a few years ago you may have had to bring up a cloud instance of a machine and then install your cluster onto it, now most of that is automated. Okay, so most of the setup of Kubernetes happens automatically when you're working with a cloud provider. Okay, so what are the use cases for a hybrid cloud, meaning using both in-house and cloud provider resources? Well, one is when you have workloads that change, and they change frequently. Okay, so if you have a website that maybe gets more traffic one day because of certain news events or certain marketing activity, and on those days it really needs to have a lot of resources behind it, and on other days it's running, there's not a lot of network traffic to it, right? So you have these frequently changing workloads. Okay, that's something that can be handled well with hybrid cloud cases. Okay, use case. And then sometimes it's a security issue. Sometimes you have critical workflows, okay, and you want to make sure that you handle those in-house so you have the most control over them. And then you have less sensitive workflows, like maybe your informational website is less sensitive than your supply chain handling application that your customers use. Right? They want to be able to order things and check on that information, and they don't want that to go down. The website you don't want to go down either, but it's not as critical to the organization, say, as another application. Okay, so you can decide based on which one is more critical where you want to load it, locally, okay, or in the cloud. Okay, another one is big data processing. Okay, so if you have a lot of data, you most likely are not generating a lot of usage of your in-house machines on a constant basis, but you might run a report, or you might run some data ingest operation that brings data into your system. And then during that time, when you're bringing in a terabyte of data, you need a lot of resources, or if you're running your first initial reduction report on that large amount of data, then you need to have a lot of machines running to handle that load. Okay, but when you're not doing that, then the machines are sitting there doing nothing. So that's the kind of thing that you might want to move out to a cloud provider, because that's one of the big things about a cloud provider, is that they can ramp up instantly from one CPU to multiple CPUs, and handle much more traffic also. So those would be two interrelated things, right? So if you're doing big data processing, that lends itself to having some of it done in-house, some of it done on a public cloud provider. Okay. Sometimes you may have decided that you want to move to the cloud, move most of your infrastructure to the cloud, but you don't want to do it all at once. Okay. So in that case, during the period of transition, you're in this situation where you're running in a hybrid cloud that uses both in-house and public cloud provider resources. Okay. And then, like the big data processing, sometimes you have temporary processing needs that exceed the amount of capabilities you have or resources you have in-house. So you want to then offload those to the cloud provider temporarily, because you don't want to have to build up a data center if you're only going to use it, now and then, So these are some use cases for using the internal resources as well as resources that are on the public cloud. Okay. So if you're looking at private cloud, which is internal or on-premises, or public cloud, which is managed, AWS, Google, things like that, we'll just go over some advantages and disadvantages. Okay. For private cloud, some of the advantages are security. Okay, you have complete, you can make this behind the firewall. It's completely secure. Okay, or it can be made completely secure. Okay, there's lower what's called total cost of ownership. Okay, so we'll see how the costs play out here, because when you work with the private cloud, you have a higher initial cost because you have to buy all the equipment and then set up the equipment. And then after that, depends on how long you use that equipment, you could have a lower total cost of ownership. You can customize things that are running on your private cloud more than you can customize on a public cloud, because in that case, on the public cloud, you can only do what they make available to you. Okay, and this brings you a certain flexibility of being able to do this customization. Now, some of the disadvantages to working with on-premises private cloud is, again, a higher initial cost. And one thing that they don't mention here is the amount of time it takes to install and get the hardware and the infrastructure running. Okay, that's something that's instantaneous with a public cloud, but it takes an amount of time, whether it's 1 week or 2 weeks or whatever. You have to deal with that delay. Okay, so higher initial cost, higher or longer delay. Okay, you are also responsible for all of that, so you have to make sure that there's nothing that's going to cause your internal resources to go down or to be compromised in any way. Okay, and also to scale your in-house items, you have to go and get more hardware, right? So it's not as easy as just saying, tell this, public cloud to scale, because they already have the hardware on a rack somewhere that you would wind up using. So that's talking about on-premises, using on-premises resources. So to use the public cloud or the managed cloud services, there's ease of scalability. You just basically tell it to scale and it goes ahead and does it. Lower capital expenditure, so you're not buying things up front. You're just paying for things as you go. Okay, and the reliability, these services, it's their business to keep those things and make them reliable. So there's a lot of effort put into that. Okay. Disadvantages, you don't have as much control over your data. Okay, and over time, it can cost more than the other approach, depending on how much you're paying for your workload. Okay. So that's just a couple of things to think about when you're trying to decide on working with a hybrid deployment situation. Okay. Here are some of the services that are part of public cloud services. Amazon has Elastic Kubernetes Service. So these specific ones here are about the Kubernetes part of those services. Okay, so Amazon has a whole range of services that you can get from them. You can even just get a virtual machine and then load Kubernetes on it. But they here have a specific offering, the Elastic Kubernetes Service, that allows you to quickly and easily create a Kubernetes cluster on their servers. DigitalOcean, Google's Kubernetes engine, IBM has their own, Microsoft. So all the big players have their own way for you to run Kubernetes in the cloud. Okay. So that's it for the hybrid cloud. We just wanted to go over the fact that that's something that more and more folks would be likely to come across now that Kubernetes is getting more popular, and because it's getting so popular that these cloud services have their own way for you to make it easy to put your clusters up on their servers. The next thing we'll take a look at is containers and this thing called Crypto, which is a command line application. Okay. So to build up to this, we need to know that support for Docker is going to be removed from a future release of Kubernetes. Okay. And what they mean by that is they're just refactoring Kubernetes because Docker handles more than what they need in most cases. Inside of Kubernetes, what is needed is a container. Okay. Okay, and Docker is more than just a container. It's also a development system for creating images and for managing containers and things like that. Okay, so inside of Kubernetes, you're going to be working with whatever containers you want to work with. We'll see a couple of examples of different ones, but generally, that part is not going to be that difficult. Because when you create an image in Docker to run in a container, Docker creates an OCI image, an Open Container Initiative specification image. Okay, and all of the other containers that you can use run those same images. So you can still wind up using Docker as your development environment for creating the images that you will place into your cluster. It's just that when they're run on the cluster, they'll be run with a different container runtime. Okay. So this changeover for Docker is already happening inside of the current version of Kubernetes, which uses this CRI, or Container Runtime Initiative interface, behind the scenes to manage containers based on whatever container engine is there. Okay. So that part is automatic. It's just, that's informational. It's good to know, but it doesn't change your day-to-day work so much. What does change a little bit is that if you're going to be troubleshooting containers, then instead of using Docker commands to get into those containers and to work with those containers, you'll be using these commands based on the CRI-CTL. Okay. So CRI-CTL is a command line interface that speaks this language, this CRI interface language. Okay. So CRI, again, is the Container Runtime Interface. Okay. This is the API, or the programming interface, that Kubernetes needs to use to talk to the container engines, to tell a container engine, load up this image, unload this image, things like that. Okay. So the different containers that are supported are Containerd, CRI-O, and there's an extra, what's called a Docker shim, that's used to support Docker now, okay, as a container engine. Okay. So the kubelet, okay, which is your agent on a node. So Kubernetes talks to the kubelet then does things on the node to start up applications and stop applications based on the commands from Kubernetes. Okay, so the kubelet talks to the container engine, so to do the actual work through this CRI interface. Okay, the CRI-CTL, which is the command line interface that can be used, so that also talks through the CRI interface. Okay. But CRI-CTL or CRYCTL is used by administrators when they want to check out a container, see how it's running, get into the container, run some commands, things like that. So here are some of the commands that you can use that are part of this command line interface. Okay. CRYCTL pods. You can list pods. You can list images. Then this one might look sort of familiar, CRYCTL ps-a. Normally, you'd be using Docker ps-a, right? So this is where you'll see a difference there. So in most cases, it tries to use some of the same commands that Docker uses, so to make the transition a little bit easier. Okay, and you'll see that here, CRYCTL exec, okay, is similar to Docker exec. It's a way for you to get a shell into a running container. Okay, you can get all the containers logs by doing CRYCTL logs, and there's a whole bunch of other commands that you can use to work with the containers when you're troubleshooting them. Okay. One specific thing that you can do is use CRYCTL to create a container, but in this case, you're not creating a container to run an application, that you're going to be scaling up or scaling down. You're using CRYCTL to create a container just for debug purposes, so that you can then execute commands from inside that container that that communicate with your other applications. Okay? So this winds up being fairly easy. You can do CRYCTL pull to pull an image. Okay, then you can create a pod, and then you can start it. So those are the three commands here. Well, once you've started it, then you can do CRYCTL exec to get into it and start running commands from inside of it. Okay. So this is just something to be aware of as you're moving forward, especially this year. That CRYCTL will be the way that you will be talking to your containers when you are doing debugging of them. And there's more information about the different commands available at this link here. Okay. Let's see the time. Okay. So the next topic, we have two more topics, is I wouldn't say it's a utility, but it's more like a distribution. It's called Kind, and we'll see what that means in a moment. And you can use it to run multi-node clusters with very little resources. So there might be several reasons why you want to do that. It's probably not something you're going to use for production, but certainly for testing and for development, it can be very useful, and for learning about how to run commands on multi-node clusters. Okay. So for a while now, this other distribution or application called Minikube, maybe something that you guys are familiar with, has been a good option for setting up small clusters. Okay. You can set up a cluster on a laptop and then work on it. You can put a virtual machine on a laptop and then set up a cluster inside of it, and then test things out and use that to test your application. Okay. The problem is that it doesn't work very well for multi-node setups. And it's only recently had that capability. For a long time, it was just you could create a single node a cluster. Okay, but there's a lot of cases where you want to separate out things like the control plane and the worker nodes into separate nodes, and you can use this other kind of utility or application called kind. Kind is refers to the name Kubernetes in Docker. Okay, so whereas something like Minikube will try to set up a node inside of a virtual machine, okay, which uses a lot of resources. Okay, when you're working with kind, when it sets up a node inside of a Docker container. Okay, and then your Docker containers as nodes can contain other Docker containers, which are part of your pods and which are part of your cluster, right? But once you set it up, you don't really have to think about that level of what's happening. You just have to know that if you weren't using kind, you would have to use virtual machines for each node that you wanted to put up, or you'd have to use bare metal, which means a separate actual machine, and you'd have to handle the networking and the setup of all those different machines or virtual machines before you ever start running Kubernetes. Okay, when you work with kind, you just tell it, I want to have this many nodes in my control plane, this many nodes for worker nodes, and it goes ahead and it creates everything that's needed to run that. Okay, so to run kind, I have a version of it running on my laptop in a virtual machine where I've assigned the virtual machine 4 gigabytes of RAM, which is not a large amount for virtual machine. And I'm using that as my machine where I'm going to run the multi-node cluster. Okay. So if you get a Linux box or virtual machine that has some RAM in it, you install a couple of items: curl, git, and docker, usually what's needed to get started. You start Docker, you install kind, which just involves running a curl command to download it, running chmod, and then moving it to a location under user bin. So it's a pretty easy install. Then you can install kube control, okay, as a separate item. Kube control is your major tool that you use to configure your Kubernetes cluster. So you install that the same way you download it, and then you use it. Okay, you check the installations with checking the versions, Docker, kind, and kube control. And that's usually enough to say, okay, we have the installation. Okay, and once you've installed it, you can immediately start creating clusters. If you want to create an example single node cluster, that's really simple. You just use this command up here, kind create cluster. Okay. Now, if you want to expand that and you say, no, I want a multi-node cluster, it's as easy as adding a config file. Okay, you see config on the second one, config kind-config.yml for YAML. And that file is very simple. In fact, you see the whole contents of it right here. Okay, so this particular config file says that when you create the cluster, that you want it to have one node that's a control plane, and 2 nodes that are worker nodes. If I wanted something different, if I wanted 3 worker nodes, it would be as easy as adding one line to this config file. If I wanted to add 2 more control planes, so to have 3 control planes where the Kubernetes management software runs, I could just add 2 more of these same lines, role, control plane. And then once I have my kind config set the way I want, then I run the command, kind create cluster -- config, and it kind config YAML. Okay, so then it takes a couple of minutes, and it creates your cluster and starts running it. Okay, it also creates a kube control config file, okay, which is what kube control needs to see in order for it to understand where the cluster is and to understand how to communicate with the cluster. Okay, so it creates that automatically for you. Okay, so once you've run this command, kind create cluster, your cluster is up and running, and you can start putting applications on it. Okay, and like I said, this uses for this particular setup here, this would use maybe 1 or 2 gigs of RAM for the cluster. Okay, which is very low, which is great. Now, if you want to check out your cluster, you want to see what's going on with it, you can use some kind commands to say get clusters. It'll tell you how many clusters you have currently configured. And then you can say kind get nodes, and it shows you here. This represents the config file we saw on the previous page. We have 3 nodes, the control plane and 2 workers. Okay, and then you can start using kube control to talk to the cluster. The first thing you do is check cluster info. And if the cluster is up and running, it'll say so right here, and it'll tell you what the URL is that you would need to use to connect to it. Okay. Then you can do kube control get nodes, where you can get more information about each node and interact with those nodes. Okay. So this is just checking it out to make sure that the cluster's up and running. And then you can run, your basic kube control commands to deploy things to the cluster. So most of this, once you've set up the cluster, works the same way it does no matter how you've set up your cluster. So if you've used multiple machines and taken a day and a half to set up your cluster, you still use kube control in the same way, okay, as you do here when you spend only 5 minutes creating the cluster. Okay. So here you can deploy an application, kube control apply, and you pass it a deployment YAML file. This one will deploy an Nginx application. Okay, once that's up, this particular one has been set up with 3 replicas. Okay, and if we look down here under Get Pods, we'll see that those replicas are running on the different nodes. You've got 2 of them running on the worker node, kind worker, and 1 of them running on worker 2. Okay, and at this point you can start scaling up or scaling down your the number of replicas that you have. Okay, so we found that using kind is a good way to set up multi-cluster nodes or multi-node clusters. Okay, for development purposes, for testing purposes, and things. It's pretty straightforward to set up. It doesn't take long to set up a cluster. And then you can start using it the way that you would use even a much larger cluster. And one of the things you should know is that kind is used by people who are developing Kubernetes in order to test their work as they're developing features. Okay, so that's a good thing to be said for it. And the very last thing we wanted to talk about today was just skill sets and training. Kubernetes can make running things on a cluster easier, okay? But it's very rich. There's a lot of things you can do with Kubernetes. It handles, the whole infrastructure of an application, including networking and nodes and things like that. So it's hard for one person to have the expertise to cover it all. So what we wanted to talk about here was different roles that can be identified with skill sets that are distinct. You have the Kubernetes administrator, somebody whose job is to administrate the cluster. You have the security specialist, which may or may not be the administrator. It may be a security specialist who also specializes in Kubernetes. Okay? And these are both separate roles from the developer who's developing Kubernetes-based applications. So each of them need to have different skill sets and therefore, training that matches that. Okay, so for the administrator, the skill sets include they need to be able to create and scale clusters, deploy applications, monitor and troubleshoot application clusters, maintain Kubernetes clusters. So, sometimes they have to, take a node offline and then restart it. But at the same time, the application still needs to keep running. So they need to know how to do those types of things. Okay. So the tasks that they'd be involved with day to day is provisioning clusters, monitoring the health of a cluster, and performing maintenance on the cluster. Okay, so that's one set of skills based on a set of tasks that the administrator would need to do. Security specialist needs to be a general network security specialist. They need to know about that. They need to know about security for networked applications. So not just for applications that are already pre-built, but for people who are developing applications, how to stitch in the networking that's part of your current infrastructure into the application. Okay? They need to know about security of the Kubernetes API. Okay, that's the way that you control the Kubernetes cluster, is going through the API, and that needs to be secured, so you can't just have anybody running commands on the cluster. Okay? And then they need to know a little bit about Kubernetes networking to understand how people can either get at or be restricted from getting at different parts of the cluster. Okay? So what they do on a day-to-day basis is to design security implementations. They decide how the Kubernetes API, that's the access to Kubernetes management of the cluster, will be secured. Okay? And they set a direction for everybody in-house, for the application developers, on how they should be securing their applications that run in Kubernetes. And last of all, developer for Kubernetes-based apps, the kind of developer who might be doing a Kubernetes first or Kubernetes native application. They need to know about application development even outside of Kubernetes. They need to know about clustering, okay, how an application runs inside Kubernetes, and how to deploy applications. So they can do that during testing and during development. Okay, so they develop applications, they test them, they package the applications. Those would be the things that they're responsible for. Okay. So just to reiterate, the reason for understanding these skill sets is to realize that there'll be different types of background information or training that these folks need to get in order to effectively be a developer or be an administrator or a security expert for the Kubernetes. Okay. So that's the content that we have, and we're coming up just about on the end of the webinar. So just go over this here. These are some courses that are offered by WebAge Solutions. So WebAge Solutions, we're the ones who put up the webinar today. So feel free to go and take a look at those. If you have the PDF file, you should be able to just click on the course name and go to the course, or go up to WebAge Solutions and look at them and see what we have to offer. Okay, and I think that's about all that we have time for. Okay, I want to thank everybody for attending. Okay, and we have different webinars now and then, so we hope to see you again at another webinar, and we hope you got some value out of your time today.